Remote sensing and satellite imagery for wildfire detection. Understanding the principles of remote sensing and satellite imagery is essential for effective wildfire detection and monitoring. Remote sensing refers to the collection of information about an object or area without physical contact, typically using aerial or satellite-based sensors. This tutorial will explore the key principles behind remote sensing and satellite imagery in the context of wildfire detection. The foundational principle of remote sensing is the utilization of the electromagnetic spectrum. The electromagnetic spectrum encompasses a wide range of wavelengths, ranging from short gamma rays to long radio waves. Various remote sensing techniques rely on different segments of the spectrum to capture data. For example, optical sensors use visible and infrared wavelengths, while microwave sensors detect longer wavelengths. Remote sensing techniques can be categorized into passive and active systems. Passive remote sensing involves detecting naturally emitted energy from the Earth's surface, such as sunlight reflected off vegetation. Active remote sensing, on the other hand, involves emitting energy, such as microwaves or lasers, and measuring the reflected or emitted signals. Both passive and active systems have their advantages depending on the application. Satellite imagery plays a crucial role in wildfire detection and monitoring. Satellites orbiting the Earth capture high-resolution images of the Earth's surface. These images provide comprehensive coverage, allowing for the assessment of large areas quickly and effectively. Satellite sensors capture data in different parts of the electromagnetic spectrum, enabling the detection of active fire, smoke, temperature anomalies, and burned areas. Every object or material on Earth has a unique spectral signature, which refers to the pattern of energy reflection or emission across different wavelengths. Remote sensing relies on analyzing these spectral signatures to identify objects, including vegetation, water bodies, and burned areas caused by wildfires. Understanding the spectral signatures of different materials allows for accurate classification and mapping. Remote sensing platforms include satellites, aircraft, and unmanned aerial vehicles, UAVs. Each platform offers distinct advantages based on factors such as coverage area, resolution, and cost. Satellites, with their wide coverage and frequent revisits, are particularly useful for large-scale monitoring of wildfires. UAVs, on the other hand, provide high-resolution and real-time data, making them valuable for localized monitoring or rapid response efforts. To effectively utilize remote sensing data for wildfire detection, certain acquisition and processing techniques are employed. These include image acquisition, which involves capturing images at specific times and frequencies, and pre-processing steps such as radiometric and geometric corrections to enhance image quality. Image processing techniques, such as classification algorithms and change detection, facilitate the extraction of relevant information from the imagery. Multispectral and hyperspectral imagery are commonly used in remote sensing applications. Multispectral imagery captures data across a few specific, discrete spectral bands. Hyperspectral imagery, on the other hand, captures data across hundreds of narrow contiguous spectral bands. Hyperspectral data enables detailed analysis of the Earth's surface, allowing for the identification of specific vegetation types, burn severity, and other indicators important for wildfire detection. Geographic Information Systems, GIS, play a crucial role in the analysis and visualization of remote sensing data. GIS allows for the integration of different layers of information, such as satellite imagery, topographic data, and land cover maps. By combining remote sensing data with spatial analysis tools, wildfire analysts can assess fire risks, monitor fire spread, and plan mitigation strategies efficiently. In conclusion, Understanding the principles of remote sensing and satellite imagery is vital for effective wildfire detection and monitoring. By leveraging the electromagnetic spectrum, utilizing different remote sensing platforms, and employing image acquisition and processing techniques, analysts can extract valuable information from satellite imagery. Integration with GIS further enhances the analysis and visualization of wildfire-related data, aiding in the prevention, management, and mitigation of these destructive events.